Alright, so we learned how to use the slope-intercept form to create an equation for a line. And you can generally do this in a bunch of different cases. If you had 2 points like I showed above, which is the most difficult case, I suppose, although that's not really that difficult. You find the slope first using those 2 points and our equation for the slope above. Then, so you'll have y equals, you'll have the slope then, and you multiply it by x. Then you sub in one of your points, one of the 2 points, either one will work. Doesn't matter which one you use. And solve for b. You might have the slope given and a point. So you might have the slope and a point given. Well, in this case, you already have the slope. So all you have to do is, so you put the slope in for m, and you just sub in point to find b. So pretty much you'll be asked in one of those two cases. All right. Okay, let's talk about the general form. Your line does not always, linear equations in 2 variables don't always end up in a nice pretty package of a slope-intercept form. They usually end up in a more general form. And your book calls it a standard form, or displays it as the standard form. That's what they call the standard form, but it's essentially the same thing, same idea. But in the general form, you're going to have an ax plus a by plus a c equals 0. This is essentially the general form. I don't think you need to really differentiate between these two, because this is just, the standard form is just the general form written a little differently. Ax plus by equals c. And since this is a constant, the sign doesn't really matter, because whatever you stick in there is going to have the sign. If these were representing the same line, then c here would be positive or potentially negative, and c here would be the opposite, negative or potentially positive of that. But let's just think about this in the general form. For example, say we have 4x plus 2y minus 10. In these situations, b, a, and c are all constant. When you have a constant multiplied by a variable, you'll call this a coefficient. So these two are coefficients. This is just a constant on its own, but these are actually constant coefficients. They're always going to be a constant value times the variable x or y. But when you look at this, it's hard for you to just look at this relationship here in the general form and figure out how to plot this line. I mean, what's the slope? What's the y-intercept? You can't just necessarily, without a little bit of practice, pull that out directly like you can in the slope-intercept form. So one of the things that you typically do is you convert this, say, to slope-intercept. And we do that by solving for y. Solve for y. Okay? So let's do that. So that means we want to get everything on the right side of the equation, except for y. So let's do this a couple steps. 2y equals minus 4x plus 10. So you want to do the algebra to double check me on your own. So I'm skipping the detailed steps here that I usually do. And then I've got to divide both sides by 2. So I'm left with y over here. So y is minus 4x plus 10. This whole side divided by 2. So I can split this up into minus 4x over 2 plus 10 over 2. So minus 4 over 2 is minus 2x, and 10 over 2 is 5. So in slope-intercept form, this takes on the form y equals minus 2x plus 5, which means our slope is minus 5, and our intercept is equal to 5. So one point, of course, is going to be right here. And then I have a slope down. This is going to be sloping down negative at 5. So I go down 5. So this is the same thing as minus 5 for a rise and 1 for a run. So 1, 2, 3, 4, 5, 1. This is another point, and we'll have to check to make sure we did everything correctly. Let's go with green. So that means that this point down here is 1, 0. Let's slap that in this equation and make sure it works. So 4 times 1 equals 2, or plus 2. And when I do that, I get 4 times 1 plus 2 times 0 minus 10 equals 0. Oh, hold on a second. That means that 4 equals 10? No, something's wrong here. And I see what is wrong. I've got a slope of minus 5 here on this line that I drew, because I said my slope was minus 5. But hold on a second. I calculated a slope of minus 2. So for some reason I wrote minus 5 there. Now let's try it again. Okay, I've redrawn this now. So essentially I have minus 2. So it's like same thing as minus 2 over 1. So our rise is minus 2, so we're down to 1, 2, and then over 1. So 5 down 2 is 3, and over 1 is 1 in this direction. So our point pair is x equals 3, y equals 1. Let's check it out. So now my relationship is 12 and yet another mistake. I called my point pair incorrectly. This is the point 1, 3, not 3, 1. So that's why we check these things. So now I've got 4 times 1 plus 2 times 3, and I get 4 plus 6 minus 10, which is 10 minus 10 equals 0. Now I feel comfortable that I've got this correct. So it stinks when you get the problem correct, but you make your mistake in your checking your answer. But it's all part of the process. Okay, so now let's think. Suppose we have a horizontal line in our Cartesian coordinates, and it goes through the y value of 4. How do we write the equation for that? Well, again, we could use our slope-intercept. And here, it's pretty easy, the intercept. Go through the point 4 for the intercept. So what's our slope? Well, our slope has no rise. So it has 0 over whatever our x2 minus x1 is. But there is no rise. And 0 over anything is 0. So for a horizontal line, your slope is 0. So that means that this is y equals 0 times x plus 4. And we can just get rid of this as 0. Or we write this y equals 4. So whatever intercept on the y-axis you cross with your horizontal line, that's going to be your y-intercept, and you don't have any slope. What if our line is vertical? Maybe we cross at x equals 5. Vertical line. Well, here we have no run. The difference between our x values is 0. So now we have, for a slope, rise over 0. So we do a little algebra here. 0 times our slope equals our rise. And say, well, does this have a value? It doesn't. It could be any value. Because 0 times any number is 0. But it doesn't equal anything other than 0. And we know that the rise is not 0. So it doesn't seem like there's a definition for this. Yeah, we call this undefined. That up there is, undefined. Anything over 0 is undefined. So you can't write an equation for this. It's just a vertical line. You can't write a relation. You can't write your slope intercept form equation for this line. Okay, there's some other topics about parallel and perpendicular lines in this section, but you guys can look through that on your own, because I think I'm going to end here with my discussion on lines.